Hello, everyone. Welcome to another binary episode of the Day Zero podcast. I'm Spectre. With me is Z. Before we get into any of our topics, Z will get into the spot the vuln, and then we'll get into it.
Yeah, and this week's Spot the Vuln, I think, should be somewhat straightforward for most people, especially if you've done any web stuff. There are multiple solutions to it, even. All the code here is doing, we've got this on line 11 def fetch URL, basically just grabbing a URL and doing something with it. I've had some thoughts about, or some suggestions that this may be a remote code execution when you have the result or sub process run with the URL being in there. I just want to be clear, this is more or less how you should be doing code execution if you need a call out to another binary, is using an array where this way sub process run understands that like curl is one specific argument, URL is another specific parameter, so you can't like inject a quote and escape and do extra. Plus, since I'm not running with shell equals true, it's not even going to put in a shell, so you can't like do shell expansions and stuff. Effectively doing it, the right way here. So that's not the issue. The issue, or all I'm looking for here, is the SSRF idea. Check URL, so it gets that URL and fetch. Start line 11, line 12, does a check URL on it. Just has an example whitelist. And all it does there, line 6, URL starts with HTTPS and then like the actual domain. The problem with that check is, yes, it checks if it starts with that, but you can have more after that point. So the solution I had in my head when writing this, though I kind of recognized there's probably going to be more coming up, and didn't think too hard about trying to prevent anything else, because this is something I've seen in the wild as a verification. My idea was using an @ sign. Curl will treat that as credentials before the actual domain. So if you do like example.com at attacker's website, curl will resolve that down to attacker website and send the HTTP auth with it. You can also do subdomains. I think that's been the more common solution that's been messaged to me. Completely fair way of going about too. I think we've even talked about that in a couple episodes where that has been their bypass. Example.com, .attacker.com or something. Again, takes it over to attacker.com's control because they're not parsing out the full host name here. So really just insufficient whitelisting leading to the SSRF. Somebody did mention a potential curl feature that they might be able to get. Like curl was doing or supported some sort of expansion. I didn't look into that. They had the thought they might be able to get a code execution out of it, which if anybody digs into that, I would be interested to hear back on it. But only solution I was really thinking of was just bypassing that check URL.
Yeah, that would be really interesting with getting code exec. So I hope they post it in like the Discord or something. If they manage to get it to work out.
I'm not sure if they followed it up or if it actually would have worked out, but sometimes applications have those very nice features that can lead to code execution with limited actual access.
Yeah. With that said, we'll get into our first topic, which is from Microsoft and is a Prevesk in Linux they dubbed NimbusPwn, which focuses on dbus a little bit here and the network D dispatcher component in systemd, where they found multiple issues. Just reading through the code. The reason they chose network D dispatcher specifically is because they were auditing and doing some live analysis on the system bus, and they noticed that network D dispatcher ran as root, and obviously that makes it an interesting target for Prevesk. So they looked into the code flow, and basically what this dispatcher would do is it would register a signal receiver on the system bus, and the handler for those signals would do some basic checking on an object path that gets sent in, and parse it for state data, passing that data off to handle state. If that state was non-empty and it was different from a previous state, it would run this run hooks for state method to update it. And this routine is where they started discovering bugs. Basically, this run hooks for states routine would build a path for scripts to run using the user provided state path. So it would build up as like, let me just pull it up on the screen. Let's see. Yeah. So etc network D dispatcher state D. But state was obviously user controlled. and they didn't have any checking against directory traversal at all here. So you can just traverse outside of that protected etc network daemon directory to get files you control evaluated. Another problem is both the script discovery code and the subprocess launching for running these scripts will follow symbolic links, which on its own might not be significant, but when you chain that with the directory traversal, it opens up a TOCTOU time of check, time of use type issue, because like while you could use this to get some arbitrary script outside the protected network daemon directory put into the script list, it will still be checking the script file is owned by root and executable. So, there is a little bit of protection left, where you can't just run like user script files that aren't owned by root. But because of the talk to aspect, you could basically link to a root owned script file for building up the list of scripts, get it put in the list, and then swap out the link to whatever malicious script you want when subprocess is actually invoked on that path. They go into a little bit of detail here on how they POC this and increase their chance of success with hitting the race. For that, I think they just basically used a lot of files to give them more chances of it being successful. And then after they managed to prevesc, they plant a root backdoor, set you at binary in the temp directory for persistence. But yeah, I mean, the main thing is just that directory traversal and the fact that links get followed. And they're evaluating they're looking at the script in two different places, right? They're looking at it for putting it in the list, seeing if it's a viable script, and then also executing it later. So yeah, those three things put together, they were able to chain into an LPE. Nothing super crazy. We've seen similar attacks before. Although this is kind of an interesting scenario where you're combining them in this way. I don't know if we've seen them combined exactly like that before, but we could have. Because, yeah, this is a pretty common issue. But, yeah, overall, interesting LPE from Microsoft. And it seems like dbus and these kind of services that are running on the system bus are pretty soft targets in Linux. I don't really know why. You would kind of suspect them to have been looked at and kind of hammered a little bit more. But the last year or two, we've seen multiple issues like this on dbus that are reliable and pretty easy to exploit. And this is just another one to throw onto that pile. So
Yeah, there's been like just said, several of these kind of Linux. Well, a lot of them have been Ubuntu focused. We've done a number of or we've covered a number of vulnerabilities just on Ubuntu, and I think the main reason for that has just been the fact that there's actually a bounty for doing so with Ubuntu, versus most other Linux distros. And I feel like that bounty might, in part, be why we're actually seeing some of these things actually getting looked at now, is because it matters all of a sudden. Like, people can get paid for it.
yeah, there's actually interest to look at it now.
Yeah, like there's a motivating reason to start looking, and if I had to make a guess, that would kind of be why. Maybe not. But that's kind of my initial hunch without having actually looked into it too much.
Yeah. All right, so Microsoft kind of looked at a Linux vulnerability, and now we have Project Zero looking at a Windows vulnerability for the next topic. This was a RCA that was put out by Google Project Zero, though is also a separate blog post from the same author, Sergey of Pixie Point Security. But yeah, this was a bug that was discovered in the wild in the Windows Common Log File System, or CLFS, which was a logic bug that led to code execution. So the RCA here starts off with some background on the CLFS format. Although not as much as I would have liked. I think the other posts did a better job of that. Um, Actually, let me just see if I can find that other post quickly. I think I have it.
Keep going. I've got a link here. I'll bring up.
You have a link? Okay, awesome.
Yep.
I just wanted to bring up the diagrams because they're very useful. So yeah, they talk a little bit in this other blog post about the background of the CLFS format, specifically this log block structure for log storage, where it has like this control block, base block, and truncate block. And those also have shadow blocks, but that's not really relevant for this vulnerability. And there's two things notable about the base block specifically. First of all, each block has a 2-byte signature attached to it, which gets encoded for consistency guarantees. And secondly, that signature is tracked through an offset in the log block header. Another important data structure with CLFS is this idea of containers or contexts. So basically, these CLFS base records, these record entries also have a header which associates that header to a context, which has some sensitive fields attached to it, such as kernel pointers to the root container class called pcontainer. So obviously, when a log file is being loaded from disk, that pointer has to be zeroed out, or it could just be user controlled and get followed by the kernel, which would obviously be a bad thing. So the load routine does zero out that pcontainer field after loading the file, but before doing anything with it. The problem is the signature offset in the block header is not validated properly, and it's possible to get the signature offset to intersect with a context object. So I believe what's going on here, they don't really explain this too well, unfortunately, but I believe what's going on here is it's possible to smash that p container field when the signature decoding occurs to fill it with an arbitrary pointer. So anywhere that pointer gets used is potential memory corruption primitives. In this case, the remove container method, which gets called by load container queue, will follow either the destroy or there was one other function pointer, I forget what it is, but there's two function pointers in that p container field, and they get followed. So yeah, sorry, the remove and release methods, which is what I was thinking of. So yeah, you could set that remove and release method to point to whatever you wanted for arbitrary code execution. There is a bit of a stipulation there. They point out that there's one bit of code when doing the decoding earlier, where it has to fail to acquire a container context so that it doesn't get released and re-zeroed. They say that's easy to accomplish. Unfortunately, they don't give any detail on how that's actually accomplished, and without being familiar with CLFS, I can't really comment on that. I wish there were some things that were explained a little bit better here for people not familiar with the subsystem they're talking about, but yeah, unfortunately, just don't have that information. But yeah, the root issue here is just the fact that you can intersect signatures with a context, which, when decoded, gives you some corruption over a kernel pointer to the parent container class. Um, Little bit of a complex code flow going on there, which isn't fully explained, but you can get the general idea from the original blog post and from the RCA. Um, as always with Project Zero, RCA goes into some detail on how they think this issue might have been found. They kind of lean towards manual review because there is some special setup that's required to hit this scenario. You have to rely on the base log record remaining uncorrupted from the encode and decode operations, and that acquire container context function has to fail, which might be possible to hit with fuzzing if you're doing like fault injection or if you have like just the right test case. But they kind of lean more towards code auditing being more likely.
Yeah, I mean, the fault injection is a bit of an interesting case for it. I mean, getting testing to hit those error cases, doing that, I mean, if you could inject, like, because this is an error case, but I don't think it would be caught with most fault injection type systems, which are going to try and cause the faults at earlier stages, or like at a lower level than the app code. So yeah, I'm not sure that would have really worked out here, but it is an interesting approach nonetheless. That turns up those. I mean, a lot of edge cases happen to be also where things go wrong. So, I mean, it's a good approach regardless. But yeah, I mean, I kind of agree with the assessment there, going towards code auditing, reverse engineering of it. Just given kind of the earlier state requirement, that feels more likely than fuzzing, but it's possible, I guess, with fuzzing too. So basically just agreeing with everything that's been said.
Yeah, like you said, kind of an interesting bug, and probably failed to get caught for so long because it kind of involves code that's not tested as much with those error cases where it's you know developers never want to do error handling. They're just like, oh, we have to handle this. Okay, fine, let's just do this quick branch and return or something. Like, don't it's easy to just skip it and not really think about its impact on the security side of things.
Yeah, well, especially like it's really easy when you're designing the code to think through, here's how I want it to work, and then when you need to start thinking about all of the error cases, and all of the consideration that needed to be made about the state in those error cases. Like, you're already dealing with the uncommon case and like the exception, not the rule, not the plan. So like you're already kind of stepping out of the mental model that you've created for your code. It's just a challenge to do when it comes to actually doing the development. Like, not necessarily like developers don't want to deal with errors, just it's genuinely it has some extra like mental overhead to do so that makes it more challenging.
Yeah. All right, so up next we have a Talos report on a bug in Accusoft ImageGear, and I'll let Z take this one away.
Yeah, I mean, kind of talking about developers keeping a clear mental image of what's going on here. In this case, the root of the vulnerability is pretty straightforward. You have kind of a table, this RGB or table MySys are. So I'm a little bit unclear on one thing because they do RBG and RGB in other places. I imagine that's just a typo and it's RGB all throughout.
I
But
guess
so they've got the table, my's RGB pointer, or they've basically got this table, pointers in it. Doesn't really matter what it's actually doing. What matters is if you provide a file, and this is IOCA type files. I'm not too familiar there. This ImageGear library supports like over 100 different file formats, so it supports a lot of different things. You provided a file with effectively the size set to 0, so size Y specifically. Setting that to 0, and then the initialization routine basically does an iteration from the count of size Y to 0. And so when you give it a value of 0, it never initializes it, never puts a pointer into that table. Although will allocate some space with a malloc 0. So it allocates a bit of space, it gets a buffer for it. Never actually fills that in, and then later on when it's cleaning up in the operator or in the deletion operators, so like C++ calling delete, when it gets to that point, it's going to try and free the 0th index or whatever index of it. It'll try and free pointers in that table, leading to kind of free this arbitrary free or freeing of the uninitialized data. They don't go into the actual exploitation of this. So how they were able to, groom heap memory to get exactly what they want there. Given this sort of application, the usage of allocations there, I feel like you should be possibly get something. It doesn't feel like it would be too hard to coerce that value to spray it somehow because it's doing a lot of loads with user data, but it is going to depend on how this library is being used.
Well, there's kind of two things that I'm thinking of with this exploit scenario. One is the fact that you're essentially going to be allocating from the smallest cache possible, or the smallest slab, because you're dealing with like malloc 0 should allocate from the 8 byte cache. Sorry, what I'm I'm trying to remember the glibc terms for like how they call it, because I'm thinking in kernel terms with cache, but that's not the fully correct term there. But ultimately, it's going to be allocating from the smallest bucket possible. So that's going to limit your reliability, especially if there's a lot of allocations happening. The other thing is where this is kind of an arbitrary free type situation. You will probably need an info leak to be able to exploit this, because you're going to need to know the pointer of what you're trying to free in order to pass it in. They don't really talk about, or they don't seem to talk about like mitigations here, like if ASLR is in play, but I would imagine that it is. So yeah, it
like
seems
your
like something you would
actual
have to chain with another bug. And the exploit scenario might not be super easy or reliable.
so like your actual full exploit chain, you need more, and you need more information about the context. What we're given here, we just don't know enough about what's going to happen, where this is really going to exist within, and all of that. All I was really getting at is like I do feel like you should be able to get control over that allocation. Although fair point on it being a fairly small cache, it's going to be fairly active. That is going to make it difficult to hit. And actually, I guess given where this happens, it happens late into the parsing of this file when it actually goes to clean it up. Oh, fair shout that actually maybe you might not be able to get user controlled data there too easily. I can imagine being able to get your data into the allocations. But yeah, fair point. Belika and StreamAss does 0 byte malloc even allocate. Generally speaking, yes. Most allocators will return on a 0 byte allocation. They'll just return basically their smallest size. So, whatever the header size is, probably round it out uh to like whatever alignment they want. But yeah, they'll generally like PT malloc will return an allocation there and stuff.
Yeah,
Most do. They can handle it as an edge case. I think in theory, like it is allowed to return null there, but most don't.
touching on that a little bit, what I was trying to think of with glibc earlier, yeah, it would be the 16 chunk size bin that would be returned. I was thinking 8, but I think 8 is too small because when you start thinking about like SSE and whatever, I think you need the ability to have a 16 byte allocation. So that's probably why it has to be aligned to 16 bytes. Um, but yeah, so yeah, malloc 0 in glibc will give you a 16 size allocation. It's not super intuitive, and it has been a source of bugs before, where people think like, oh, I'm keeping my sizes and stuff consistent, and I'm doing some rounding, and they don't check for the possibility of rounding to 0 in like an int overflow type situation. And maybe they do think of that case, but they think, oh, malloc 0 is nonsense anyway, so we don't have to care about it. But yeah, it does end up allocating in most allocators, and yeah, it's weird that it does. It really should return a null pointer, but that's not the way it works for
See,
whatever reason.
I kind of feel like it makes sense to bring back because you're asking for an allocation. It's just like you're giving me a nonsense value. I'm giving you a nonsense output. I mean, granted, I'm saying nonsense. Maybe that doesn't make sense. I don't know. I was never struck by it the same way. I know we had this discussion like years ago where you were surprised by it too. I don't know. It never seemed all that surprising to me, but out of chat, 6A0BCD80 asks, did they just find this bug on accident? Can the company sue them for finding this exploit because it violates copyright issues? No. Keeping it brief, it's not a copyright issue to find bugs. I'm not sure where your thought is on why this would be violating their copyright. It would be violating their copyright if they were, say, using a cracked version of it to find bugs on it. That said, generally speaking, when it comes to this type of vulnerability research, where they could sue you for is if you were testing without permission. The key thing here is this is running on like the security researchers machine, so probably a fuzzing box something, but they're running this locally, so they're not compromising a computer of anybody but themselves, so they have ownership over that, so you can't be sued for it. Like, they don't get to control your computer. That's why you can test Windows, for example. You can run that all on your own and you're not compromising anybody else. If it were a remote server, so where you run to it a lot more is in web, randomly testing somebody's website, even though it's your account you're trying to break into or something, you're still breaking onto somebody else's computer, you're involving their hardware, somebody else getting involved. When it comes to software running it locally, there are very few avenues in which they can really come at you for it. Only place I can really think of is when it comes to licensing and disallowing the
Hmm.
testing through licensing.
Yeah,
Um,
if you're testing something to try to circumvent DRM, or like you're trying to break encryption keys or something, then you're getting into more dangerous waters. But with something like this, no, you're pretty far away from that.
yeah, that's a fair shout. DMCA in the US effectively allows you to do testing as long as it does not enable bypassing copyright. Um, So, like, you can't release your method to defeat some DRM, even if the DRM is extremely stupid and, like, oh, it just adds a null byte to these files and you can decrypt them by removing it. Like, that wouldn't be allowed. You would be violating DMCA then. DMCA is just really stupid in a lot of ways, so I'm not going to go on my rant about that. But no, generally speaking, this sort of research is generally going to be okay. The main place I could really see there being an issue is if like the license to use the software didn't allow it, but then that would only be like they could take away your license because you violated the license agreement, not so much suing you for it. And definitely not any sort of criminal case. At least I should preface this by saying I'm not a lawyer. I've spent some time in discussion with some lawyers over this sort of thing. So I have a little bit of background, but like I'm not a lawyer. So it's my understanding, and that's all.
All right, so we'll get into some of the research topics that we have for this episode. First of which is an article by Quark's Lab about a new vulnerability dataset they've put together, which interestingly has both fixed and vulnerable states and binaries in the dataset for testing tools and such. So we've talked in the past about some of these vulnerability datasets before, mostly in passing when we were talking about some fuzzing paper that mentioned it. Or I think it was a long time ago now, but we talked about like larva for synthetic vulnerability injection and stuff like that too. But
Lava, yeah, lava and magma.
yeah, sorry, lava and magma. So yeah, these types of data sets and tooling can be very useful for testing like your fuzzer or your SAS tooling or whatever, to see if it can catch certain types of bugs, try to do some targeting, things like that. Sometimes, like we mentioned with lava and magma, they're comprised of synthetic bugs that just get introduced. But this Vuln dataset is comprised of real vulnerabilities from CVEs, specifically from the Android open source project, which they chose for a few reasons. The most prominent one being the fact that AOSP has security bulletins and advisories that get published monthly. So that offers a nice, like, centralized resource where they could pull issues from, and get like the relevant versions of binaries to do some diffing from. So yeah, from there they do some automated patch diffing and compare the binary artifacts to get the fixed and vulnerable binaries. They talk a little bit about some of the challenges they face here and the limitations, such as the fact that the component diversity is very low since they're only pulling from like the Android AOSP here, um, and the fact that it relies on things like Google's Android security bulletins, which is a single point of failure because if Google doesn't put one out 1 month for whatever reason, or if it's missing some information, um, that's gonna impact their data set. They're not going to be able to pull that information that's not there. They're only taking it from a single source. Beyond that, they talk a little bit about the data set itself and the structure of it for those who would be interested in using it. But yeah, I mean, overall, I just wanted to shout out the data set itself and the fact that it's there. Because if you're developing like fuzzers or whatever, you want to know that it can actually find issues. Um, and that's pretty hard to do with 0 days if you don't know what the issues are. But with these kinds of data sets, it offers a venue for testing that tooling and making sure that it works. So yeah, these kinds of data sets are useful when they come out, and that's why I wanted to shout it out.
Yeah, and I guess I'll show the other thing since we were talking a little bit last episode about like choosing a project, choosing a component, and about using the known CVs and stuff. This sort of data set, bringing it all together. Um, you can kind of pay attention to certain hotspots where there have been trends and all of that. There's just some interesting information to be had out of this sort of collection.
All right, so for our last topic, we have a research paper on data AFL flow or
Yeah, it
data
feels
flow.
like a while since we've done a good fuzzing paper.
Yeah, it has been. So yeah, this is a paper on data flow guided fuzzing, which is kind of an alternative approach to your more typical code coverage guidance, which is been the dominant form of instrumentation and fuzzing guidance for years. And data flow guided has its own kind of advantages and disadvantages compared to coverage guidance, which they talk a little bit about in this paper. For example, they point out that while coverage guidance is performant, and that's part of the reason why it's so prominent, it fails to capture some useful information about the state, notably how an input is actually consumed by the target. Um, so, like, you can kind of infer how an input is consumed with the coverage it produces, but only vaguely. You can't really determine exactly which mutations or changes on the sample led to new program behavior very easily. And they say the differences in data access and manipulation within a single code path get lost with coverage guidance. And that's kind of some of the problems that they hope to tackle with data flow guided fuzzing.
Yeah, there are like I just want to jump in. A few other approaches that they touch on a little bit being taint analysis. If you've used lip fuzzer, they'll do edge coverage rather than just the basic blocks. They'll know like which way it jumps between them. So passing into an if statement versus just going from the stuff before an if statement through to after it would cover the blocks, but making sure you cover both skipping the if and taking it, basically tracking the edges. That's kind of getting into the realm of also like comp log or what was it, Red Queen, I believe is the fuzzer's name, doing kind of more dynamic taint analysis, which is a little bit more performant than doing this proper data flow analysis and using that to kind of influence. Actually, yeah, they call it out here. LLVM has a DF or data flow sanitizer, um, that implements a sort of dynamic taint analysis. This is getting like the data flow analysis that they're trying to do here is, in a sense, more true data flow analysis rather than this more performant option. And I also want to shout out, like, I really appreciate the fact that as a paper, they call out like that this, they don't call it out as this was less than positive, but a lot of times with papers, we mention that they seem to be overplaying their results a bit. They don't seem to do that with this paper. They call out, we did our preliminary evaluation of this, and our initial results suggest that so far coverage, peer coverage, remains the best metric rather than the data flow coverage. So, like, they're calling out, like, hey, this didn't work everywhere. Here's an area where it shows some promise, though. Yeah, just wanted to also shout that out, but jumping back onto the technical details, there are some other approaches to do similar things, but they are taking it much deeper, I guess is what I'll say. Trading off that performance for this alternative approach that can pick up other types of bugs.
Yeah, so they talk a little bit about like how they do the data flow guidance. This figure 3 on page 4 kind of does a good job of summarizing it a little bit. Where they basically have two lattices. One that tracks definitions where variables are partitioned on their types, and one that tracks variable accesses like reads and writes and what information about that access is recorded, such as like the offset or value. And these chains called def use chains are used at runtime for tracking and doing mutations and stuff. That's not really like new from their side. That's from kind of an older paper. Z pointed this out to me a bit because I didn't notice this right away. But yeah, this was that like idea of using these sensitivity lattices are from a paper from 1991, called Data Flow Coverage and the C Language. But yeah, like Z touched on, unfortunately, their results didn't seem to be what they hoped for, saying
Yeah,
that it provided little benefit, but they're going to look
adding
into it further.
adding in a little bit on the 91 paper, like, yeah, the paper here, like, what they're doing here is they're applying data flow analysis into the fuzzing system and kind of giving the whole system here. That's what's new about this paper, not the actual data flow technique. They're using a well-established means of doing this data flow analysis. So yeah, from the papers from 91, obviously that doesn't make all of this old. This is still novel research.
Oh yeah, yeah, that's fair to point out. Um, yeah, personally, I don't know. I find this kind of interesting with using data flow. I don't really. One of the things that struck me when I was reading this is like, okay, personally, when I use coverage guidance, what I find it really useful for is getting a quick introspection of the code. Like, how is my fuzzer doing? How deep is it reaching? With coverage guidance, that's very easy. You just take a look at like a lot of fuzzers and stuff will come with like a code viewer or something, and you can look in the files and see exactly where your fuzzer is hitting and where it's stopping, like where it can't get further code coverage. With Dataflow, that seems a little bit tougher to get at like a quick glance. So on the manual side, it seems like it would be more annoying in that sense. Um,
So I
I
didn't see
almost
how they do the visualization here, but I feel like because you are still using the definition sites and the use sites, you're still able to overlay this onto code. So even though it's not like a
not to
line
the
by
same
line
degree though.
coverage, but like you can see, well, just by the use sites, even you can see the areas that are getting covered.
Mm,
Because the use sites are going to be somewhat of a proxy code coverage. So like you can overlay it and be like, yes, these conditionals were reached in these ways with these sorts of things, and just you basically are adding more information to the code coverage, and what you're losing out on is like the basic block coverage. It's looking more at just the data accesses.
yeah, I
Or,
don't know.
yeah.
I'm just a little bit interested on how it is, like how it would look from the manual side of things with trying to judge how well your fuzzer is doing and looking at the metrics. I don't fully know. I'm just kind of going off of what they're talking about here and
Yeah,
picturing
I'm
it in
not
my
sure.
mind. But
I'm not sure how they do it here, and obviously the other part of that is the mutation engine and all of that is going to be mutating based off of getting new data flow. Um, so if you're just leaving it on its own, the data flow is okay. I get where you're coming from though. And I wasn't actually thinking about that. But yeah, in like a normal campaign, you also work in your test cases and new new seed or whatever. You're gonna look at that coverage as you're just saying, and then, why am I not getting coverage here or there? I feel like with the right like overlaying this onto code, again, I don't know how they're doing it. I feel like you could do that with the data flow though. I'd maybe even just want to. Okay, sorry, I had an idea, but already rejected it. I would kind of leave this as I would imagine you can overlay this over code and get a decent idea over where it's going. Maybe not at the code coverage level, but at the level, or not at the specific basic blocks, but at the level of you're hitting these use cases, like these parts of the use chain. I feel like that can tell you quite a bit. At least in my mind, I feel like you can do a very similar process in your normal campaign using that information versus code coverage. Like it doesn't concern me as much as it seems to concern you. Although that would kind of be something that I'd leave to judge until I'm actually trying to do it.
yeah, nonetheless, I think the research on this like data flow side of things is interesting. And they do say, they're going to continue looking into it, see if it can be made more viable than coverage guidance in some certain scenarios. So yeah, I mean, I think it could lead to some nice innovation and much hope for innovation in fuzzing because uh, we've kind of talked about this before with like CTS on, but for the most part, fuzzing over the last like 5 or 6 years hasn't really moved that much. AFL has kind of been the big change that happened with introducing like coverage guidance in this way, and beyond that, there's some tricks you can take advantage of that in hyper specific scenarios are useful, but in a general sense, they're just not really going to be offering anything over what AFL already does. So yeah, it's always nice to cover some new fuzzing research, which we haven't done in a while, as he said. So yeah, kind of an interesting paper, and one that you can appreciate where it doesn't try to cherry pick results to make it look better than it actually is, which was a problem that we used to have with a lot of the older fuzzing papers we covered, and is part of the reason we stopped covering them so much, because it just felt like we were kind of taking shots at the conclusions for a lot of them.
Yeah, I
But
a lot of the papers also kind of felt like they were doing the same thing, just a slightly different way. Like, oh, we're applying a SAT solver in this new way, or not even a new way, just like to a new system. And like a lot of them felt really kind of cookie cutter papers, just not really adding anything new, but technically new. This one though, like using the data flow, like I think it's a great idea. I'm a little bit surprised there isn't actually more research onto this, although I think performance has been a big thing to hold that back. Um, but even with what they found here, like yeah, they're finding that coverage once again. It's kind of showing itself um to be kind of the best thing we have available. But there were cases where the data flow did outperform just standard coverage, and I think that's important because that's basically the cases where um basically like parsers, things like that, where the data flow matters a little bit more than just what are you getting coverage over. So it feels like with more research, there are probably places where data flow will be the choice, and it's just going to be one of those things where rather than always reaching for your generic fuzzer, it's what is my problem? What is the tool or target that I actually am going after? And then deciding, is it a good idea to use DatAFLow here? Is it a good idea to use coverage? Um, I feel like that choice can kind of be made at some point. Like there are going to be there are going to be targets where DatAFLow makes sense. So this research is just starting to actually poke at that and see where can we apply it, and actually trying to do so in a reasonably performant way. Um, Code coverage was better, but DatAFlow didn't like perform poorly by any means either. Uh,
Yeah.
like
Um,
you'll, sorry, I just brought up the graph here. But you'll see like there are some differences on the graphs in terms of like how quickly things jumped up or where they got. Like, basically these graphs have different shapes, but they all still kind of got towards the same end location, basically, is all I'm talking, or all I'm getting at. So DatAFlow seems like a viable route here. I'm interested to see where more research goes. Perhaps there has been more research that I'm just unfamiliar with. It's not like I'm reading absolutely every paper that comes out. Uh, but yeah, I mean, I thought this was a good paper, and I appreciate the fact that they're effectively being honest about the results here, so we can actually learn from that instead of only seeing these very positive results. So, again, good on them for that.
yeah. So I think that's a good place to wrap up the show. So yeah, that's everything we have. Thank you everyone who tuned in. VOD will be up on YouTube and Spotify and other platforms tomorrow. Remember to follow our Twitter and join our Discord if you want to get involved in the community. Links for those are in chat or on the website. And yeah, with that said, we'll be back next week. Until then, take care.